So, a video was taken days after a severe snowstorm that happened last week in Vancouver. So, those of the viewers living in colder climates, slippery ice is not uncommon in winter, especially in skating rinks or frozen ponds and on dangerously slick roads and sidewalks. So, why is ice so slippery? Well, the question might sound simple, but it's actually not. So, water spilled on floor can create the same kind of hazard for walkers and drivers as ice can. So, presumably, the liquid makes the surface slippery because liquids are mobile. So, asking the question why ice is slippery is almost equivalent to asking how a liquid or liquid like layer can occur on the ice surface in the first place. So, different scientists have different ways of answering this simple question with three different hypotheses. So, the first hypothesis is that pressure can melt the ice, and that is why ice is slippery. So, this was thought of by James Thomson in 1850. Um, who developed an expression for the linear dependence of the freezing point depression on pressure. His brother William Thomson verified that result experimentally, but none of them considered ice skating until 1886 when a young engineer named John Jolly worked to solve the problem. Referring to Thomson's results, Jolly pointed out that the pressure of a skater's blade is so great, so large, because it touches the ice over small areas. And he did some calculations and realized that the film of water is what makes the ice slippery. However, Jolly never explained how skating might be possible at a temperature lower than the temperature he calculated, which is negative 3.5 Celsius. But as we know, skating is possible in climates colder than negative 30 Celsius. And many hockey players in hockey games are at such low temperatures. So, pressure melting resulting in pressure melting the ice resulting in ice being slippery remained the dominant explanation for why ice was slippery until later on Frank P. Bowden and T.P. Hughes had a new explanation. So both of them in 1939 suggested that friction was the cause of ice being slippery. So many of you guys might know that friction is the thing that happens when you rub both of your hands together, and also something that basically stops something from moving. So basically when friction happens, heat is released, and this is what they're referencing to. So basically they set out a bunch of experiments, and they basically found out that friction heats up the ice, resulting in the layer that we see on top of the ice, the film of water on the surface of ice, which can occur at a lower temperature, which can basically explain why you can skate at a lower temperature. But this, or pressure, also both of them don't explain why ice can be slippery when someone is simply standing on it. So this brings up the third hypothesis, which has to do with more of a molecular view on the situation. So basically in 1850, Faraday discovered that every single ice cube was coated with a liquid-like layer. And his experiment was simple. He basically took a couple of ice cubes, stacked them quickly, and after a few hours, they were stuck together. So Faraday guessed that the ice cubes stuck together because of the liquids surrounding them, and when these liquids met, they froze together, which caused the ice cubes to freeze together. But because at the time they couldn't take in a more of an atomic and molecular layer of this problem, it had to be basically figured out later. So basically, when water is frozen, the individual water molecules grab onto each other through hydrogen bonds, holding one another in place in a crystalline structure. As you can see, in the lower parts of the figure, the molecules on the surface have fewer molecules to cling on, which makes them more disorganized and ultimately making the ice slippery. So these hypotheses basically explain why ice is slippery. Maybe you have your own hypothesis or your own explanation. Thank you for watching.